In this question, we're given 4 points, A, B, C, and D, and we have to prove that each of these points is actually going to lie on the same circle. Okay, so how might we do this? Well, all we really have to do is find a circle. Doesn't matter how we find it because the question isn't interested in that. Once we've found a circle, we just have to show that each one of these points is going to satisfy the equation of that circle. And if that's the case, then each one of these points must lie on that circle. Okay, so how do we find this circle? Well, if you think about it, if the circle is going to have each of these 4 points lying on it, then it's necessarily going to have at least 3 of these points lying on it. So let me not worry about the 4th point. Let me just figure out a circle such that these 3 points actually lie on it. All right. So how could we do that? Well, we've sort of seen problems like this in the past because if you think about what we need for a circle, we really need a center and we need a radius, right? We've done calculations in which we start with 3 points, in other words, vertices of a triangle, and figure out a center called the circumcenter, which is really the center of a circle, such that the triangle whose vertices are ABC is actually inscribed in that circle. So a guess might be, let's start by finding the circumcenter and use that to find a circle such that ABC, the vertices of our triangle, are actually on the circumference of that circle. And let's check if D lies or does not lie on that circle, and hopefully that will give us some idea of where to go. Okay, so let's do that. Okay, now, if this is the first time you're coming across the concept of a circumcenter, then this video is not the right video for you to learn what a circumcenter is from scratch. This is really for someone who already knows what the circumcenter is and is familiar with standard calculations for the circumcenter and is then able to follow along. Okay, if you want to learn about the circumcenter, I'd recommend go look at some other videos on the channel which actually talk about this concept from scratch. All right. So anyway, so to find the circumcenter, we need to pick 2 sides of our triangle and work out perpendicular bisectors to them. Okay, so I'm going to start with the side AB and figure out a perpendicular bisector to AB. So to do that, I need to figure out the midpoint of AB, and we can do that by using the midpoint formula, which is you add up the 2 x positions and divide by 2. So 7 plus minus 1 is 6, divided by 2 is 3. Repeat for y, 8 plus 8 is 16, divided by 2 is 8. So we've got a midpoint. Now we need a gradient of the perpendicular to the segment AB. But if you think about the segment AB, it has y equals 8 in each case, which means the segment AB has to be a horizontal segment, which means the perpendicular to AB has to be a vertical segment. And I want a perpendicular bisector of AB, which means I want something that's perpendicular to AB and passes through the midpoint. So I want a vertical line which passes through the point. The line has to be x equals 3. Okay, it's a vertical line and it passes through this point here. Right. So now that we've figured out the perpendicular bisector of one of our sides, AB, I'm going to pick another side. And in this case, I'm not going to choose the side BC of our triangle. I'm going to choose the other side, which is from A to C. So again, I need to work out the midpoint. So I take my x position for C, my x position for A, I add them up, which is 7 plus 6 is 13, divided by 2 is 13 over 2. And I repeat that for y, which is 1 plus 8 is 9, divided by 2 is 9 over 2. So this is the midpoint of AC. I need the gradient of the perpendicular to the segment AC. For that, I work out the gradient of the segment AC, which is obviously change in y over change in x. So I'm going to take C as my x2, y2, and A as my x1, y1. So y2 minus y1 is going to be 1 minus 8, which is what I have here, and x2 minus x1 is going to be 6 minus 7, which is what I have in the denominator here. That simplifies to give me minus 7 over minus 1, which is 7. So in other words, my segment AC actually has a gradient of 7, which means the perpendicular to it, by using the standard property that you flip the gradient and you stick a negative in front, is going to be minus a 7th, right? So I can write down the equation of my perpendicular bisector, which is going to be y equals minus a 7th x. plus I'm calling the y-intercept C prime because C is actually a point we've already defined, okay? So I need to figure out what C prime is, and that will then let me know what the equation of my perpendicular bisector for AC is. So we can work this out by using the fact that this equation must be satisfied by this point. And so we substitute x equals 13 over 2 and y equals 9 over 2 into this equation, which gives us this thing here. And we solve this to figure out C prime. C prime turns out to be 76 over 14. So we've actually figured out the equation of the perpendicular bisector of AC. So I now need to solve one of my perpendicular bisectors with the other one to actually figure out the circumcenter, okay? But this is easy because this line is such a nice line. So to be able to solve this, I'm just going to substitute x equals 3 into the equation y equals minus a 7th x plus 76 over 14. And when we crunch through the numbers, feel free to pause the video and follow the sort of details here if you need to, but we actually get y equals 5. So in other words, when x is 3, y is 5. And so our center or circumcenter is actually at the point 3, 5. So we have a center. Let's think about now the radius. I can figure out the radius by basically picking any three of the vertices of my triangle A, B, or C and working out the distance between the center and that vertex. So for convenience, I've just chosen to work with vertex C. And so we can figure out what the distance is. If I call the distance to be r, which I know is going to be the radius of my circle, then we can apply the distance formula in a plane, which is basically x2 minus x1, which is here, squared, summed with y2 minus y1, which is what I have here, squared, and then the overall thing square rooted. Okay? And 6 minus 3 is 3, so I have 3 squared, and 1 minus 5 is minus 4, so I have minus 4 squared, which means our radius is 5. And so the equation of our circle, which inscribes the triangle ABC, is actually x minus 3 squared plus y minus 5 squared equals 5 squared. And so we're pretty sure that ABC are going to lie on this circle. We don't know if D is going to lie on this circle. But what we can do is we can just check, can't we? So let's call this circle, let's give it a name. Let's call it capital C, obviously because we've already got a point called C, so we can't call the circle C. So let's call the circle capital C, and let's figure out if all of our points actually lie on capital C or not. Okay, so C, we've already done this because we figured out the radius of capital C by basically arguing that C lies on our circle. We've specifically found a circle such that C lay on it. Okay, so we know that this is going to be fine. So let's check A. So we stick in x equals 7, y equals 8 into our equation. So I get 7 minus 3 squared plus 8 minus 5 squared, which is what I have here. 7 minus 3 is 4 squared, and 8 minus 5 is 3 squared, and 3 squared plus 4 squared is obviously 9 plus 16, which is 25. So bingo. So A is on our circle. That's good news. Let's try B. So again, I'm going to stick in x equals minus 1 and y equals 8. So minus 1 minus 3 squared plus 8 minus 5 squared. Well, minus 1 minus 3 is minus 4. Square that, you get 16. 8 minus 5 is 3, square that, you get 9, and 16 plus 9 is 25, so bingo, that satisfies the equation of capital C, so B is also on there. Again, we shouldn't be surprised by this, because we did a calculation such that this triangle was going to be inscribed. But now this is the important point, so let's verify if D is on there. So I'm going to stick x equals 0, y equals 9 in. So 0 minus 3 squared is essentially minus 3 squared, which is 9. And 9 minus 5 squared is 4 squared, which is 16. And then 9 plus 16 is 25. So, we've shown that D also lies on this circle capital C. So as far as the question is concerned, we've actually finished the proof. We've found a circle. This is the equation of that circle, such that each of these points actually lies on that circle. So we've shown that actually all the points lie on the same circle. Now, I would leave a question with you, which is to have a think about why is it the case that we've actually done a circumcenter calculation and the fourth point that we figured out certainly lies on the circle that we figured out. So you might want to think about some circle theorems and a bit of geometry to figure that out, okay? Okay, with that, I will bid you farewell. Thank you for watching, and if you found this useful, then consider subscribing.